Our speaker is Dr. Steve Lipner, who is currently working for MITRE-TECH, which is a nonprofit organization which does contract work for the government. In the past, he's had a long career of maybe more years than some of you are old. No, I know that some of you are old, at least one. And in computer security, he has worked for MITRE, doing contract work mainly for the Air Force. He worked for the TIS, where he was the keeper of the TIS Gauntlet firewall until he went to MITRE recently. Before that, he was at Digital Equipment Company, where they developed the A1 VSS. He is the designer of a key escrow system and has many thoughts about the commercial viability of computer security and high assurance given today's marketplace and what customers appear to be asking for. So without any more introduction, I'll let Dr. Lipner tell you his thoughts.
Okay. Let me just make a couple of observations before I got started with the slides. And the slides, are sort of my guess at some background and some things that I've observed over the last almost 30 years. I've been in the computer and information security business for a long time, though I'm quick to add, not as long as Clark, and like. And I also just, in the interest of truth and advertising, I have to point out that I don't have a doctorate. I have a master's degree, and not only that, the master's degree is in something irrelevant like civil engineering. Although I've sort of learned a little about computer security and computer science on the fly. The success of my years in computer security may be fairly assessed perhaps by the fact that I've worked for two profit-making companies, TIS and Digital Equipment, neither of which exists anymore, although I disclaim responsibility for their respective demise, and we can talk about why that was if you like. Seriously, what I want to do is to try to just give you an overview of some chronology from my perspective. Cynthia was pointing out to me when I was showing you these slides that the chronology doesn't have Multics on it, but I wasn't really as heavily involved with the Multics development and so on as I was with some of the other systems on the chronology, and it gives you a sense of sort of what's happened over the last 3 decades. I'm going to talk about secure systems and security kernels and some of the research that was done in the 70s. I'm going to talk about the Orange Book and trusted systems, and that's really sort of a background of the 80s. I'm going to talk about building and selling secure, trusted systems, and where things did and didn't get to, why, sort of what happened with the Orange Book, what has been happening. Beyond trusted systems goes a little into some of the more commercially successful experiences with security, and really talk about what people will buy, and that may not be something that those of us who are sort of in the national security and defense world might like to hear, but I think it's important that people understand what sells and why it's sold, and maybe you already have that perspective. And then I'm going to look a little at the common criteria, which is the government's current way of evaluating secure systems, talk about assurance, multi-level security, and then try to give you a little perspective on what might be happening in the future. Cynthia and I were talking in her office this morning, and she said that she had received over the weekend an email message, basically I guess sent to the entire Navy, that talked about what to do when an email message from one of the classified networks spilled, I guess that's the euphemism of choice in the communications world, and wound up on the internet. So if you get a secret email message, here's what you're supposed to do about it if you're in the Navy. And you know, we've been, I don't know, Clark and I have been trying for 30 or more years to build mechanisms that kept that from happening. And I guess we've got to try harder or something, because people have deployed this technology and it really works well, except for some things like maybe like keeping secret messages from coming out on the internet. And most of the time it even does that. But you can speculate about malice and other things, and when bad things happen to good secrets. So here's Steve Lipner's perspective, absolutely illegible. I'll get hard copies of this to Cynthia or something. I mean, this is I took an update course on giving presentations a few years ago, and they told us things to do and not to do. This is something not to do, but I don't know any other way to sort of track these events, this many events over this many years, sort of briefly. You've got the Defense Science Board panel and the Ware report, which Clark was involved with back in '65, '68. The Air Force Data Service Center in the late '60s said, you know, we need to process classified top secret and secret data on one time sharing system. Can you help us? And the answer was yes, at least for a while. And then some things, you know, like the Bell-LaPadula model, some prototypes. The Computer Security Center was formed at NSA in 1981. We started research on an A1 system for the VAX computer line from DEC in the early 80s. Actually got the system to field test in 88 or 89, I think, and then canceled it in 90. The explosion of the internet began in 94, and then my ending bullet is that 4 firewall vendors had initial public offerings and made a batch of internet millionaires in the mid-90s. So what's been going on with computer security, and what's worked and what hasn't worked, and how does that relate to people who are trying to protect you know, sensitive and classified information for the government? And I mean, you know, not all of it is real optimistic, but let's sort of see what's been happening. In 1967, the Ware report came out, initially as a confidential document. It was declassified in the late 70s, and you can get copies of it. And it basically said that computer security was a difficult problem. I guess we know that by now. And it also said that open multi-level systems, like connecting the internet to your secret network, was something that really should be avoided. And so, you know, taking that as a challenge, and working at MITRE and for the Air Force, we started initial work on multi-level security because we still had these requirements. We had a requirement from the Military Airlift Command that said they wanted to connect their unclassified and secret networks. We had the Air Force Data Service Center requirement for secret and top secret multi-level. And these were all in sort of the time-sharing system paradigm, you know, terminals and big computers that was current during that day. One of the things that happened in that era, and it's long gone, so you can talk about it, or at least I'm willing to talk about it by name, was that McDonnell Douglas Automation Company had a time-sharing service bureau in St. Louis with big 360 computers, and they wanted to use them a little bit of time for classified work, or maybe a lot of the time for classified work, probably designing the F-15, and then the rest of the time they wanted to sell time, you know, to people like me who are civil engineers designing roads and other things on them, you know, dialing in. And so they said, well, we fixed OS 360, which was the IBM operating system, and now it's secure. And so even though we have these unclassified users coming in, we'll let them, they can't get to our secret data. And so ARPA put a team together, or DARPA put a team together of some folks to come in and try and just see how good a job they'd done. And they broke in, and they got the test data. And so McDonnell Douglas took the capability down and said, well, we'll fix those holes. And they fixed the holes. And they said, all right, ARPA, come back. You can't do it to us this time. And so they did it, and they did it again. And there's some debate, and of course none of this is documented. It's sort of anecdotal war stories. There's some debate about how many cycles that went through, but eventually they gave up. And there were other tests along the way. DIALS, the DIA Online system, which was an intelligence processing system that also was the subject of penetration testing. And all the work basically involved, we'll take these time-sharing systems, we'll plug the holes, we'll maybe give them some knowledge of classified information, classification and clearance, and we'll make them operational. And all the tests came along and said, if I can get a program in, whether it's in BASIC or Fortran or assembly language or so on, I can do you in. I can defeat the controls. I can take over the system. I can get it all the data. And the conclusion we drew was that retrofits are hopeless on bug-prone monoliths. And I'll give you at least an informal definition of bug-prone monolith toward the end of this presentation. But you want to remember that point about retrofits and bug-prone monoliths. So the Air Force sponsored a panel that said, okay, there's a path to a solution to the multi-level security problem. And that path ought to involve mathematical models so that we know what we're trying to build in a security sense, a reference monitor, which is an abstraction that mediates between users and programs acting on their behalf, and data, and does so in a way that's constrained by the mathematical model, and then security kernels, which are the implementations, and are small and simple and assured, capable of being assured to be correct. The Air Force followed up on that, on the Anderson panel, to start to fill in the details. They built the Bell-LaPadula model, which everybody's heard of, and the Bell-LaPadula model was driven by the Trojan horse or untrusted software threat. And I'm going to come back with a war story about untrusted software in a few slides too. We actually built a security kernel for the PDP-1145, which was a DEC mini computer with memory mapping, and demonstrated that it could do some pretty toy applications, but kind of interesting ones. We did a security enhanced version of the Multics time-sharing system, and that was actually fielded and operational at the Air Force Data Service Center in the Pentagon, probably from, say, 76 or 77 until the late 80s, when it was replaced by a system whose security capabilities weren't as great. And we started some efforts that were canceled, a more robust security kernel for the PDP-11 and Project Guardian, which was to take Multics, minimize the operating system, structure it, and actually get to a high level of assurance with a system that would be application program compatible with the Multics operating system. Effort was canceled. Basically, I don't really have good perspective on everything. The sort of folklore was that there was a lot of politics, a lot of interorganizational dispute within the Air Force and the intelligence community, and maybe some questioning about whether Multics was the right platform and whether the developments were feasible. But by the late 70s, we thought we understood how to do multi-level security. We thought we had the technology down pretty pat. And a colleague of Clark's and mine named Steve Walker moved to the Office of the Secretary of Defense and started what was called the Computer Security Initiative to convert that technological understanding into mainstream products. And the Computer Security Initiative sponsored the national conferences that became the National Information System Security Conference, the trusted computing-based terminology that, that you see in the Orange Book, and the formalization of levels of features and assurance that would support evaluation of products for their security properties. And that work culminated in the formation of the National Computer Security Center at NSA in 1981. And the Computer Security Center in turn promulgated the Trusted Computer Systems Evaluation Criteria, the Orange Book, that evolved from the Computer Security Initiative. When we started building the Orange Book, or when NSA started building the Orange Book, the key questions were okay, so you're going to evaluate systems and you're going to characterize their security by levels. Then the question is, how do you characterize them? What are the levels? What's in each? The underlying assumption was that if you were going to do real multi-level security, like, say, connect your secret data up to the internet, you need a pretty high level of assurance, pretty high level of security, something like a B3 or an A1 system. The B2 systems, which basically have a big operating system but with some structure and certainly know about classification and security models, are okay for closed environments, but not if you're going to let the scum of the earth really get access to your system. And then below that, basically you're talking about honest users and no malice at all. The Orange Book also considered what I call market factors, motivating the vendors, motivating the users, and transition. Okay, this is not the sort of talk I'm used to where I stand here and talk. If you have questions, sing them out, okay? Be as disrespectful as you wish. It'll be more entertaining for your colleagues and maybe for me. Do they normally ask questions, Cynthia? Huh? Yeah. Okay. No, it helps me stay on track, and I'm trying to, I'm glossing over a lot of stuff, but the intent is that you'll motivate me to go into whatever details you want to hear by asking questions. I'll finish by one, no matter how many questions you ask. I promise. Okay. So the intent was to make C2 systems real easy to build, get an immediate rating, and they were sort of based on some existing products for IBM mainframes called ACF2, RACF, and Top Secret. B1 was intended basically to make it easy for vendors to introduce mandatory security, the Bell-LaPadula model, into their products, by basically just grafting security labels onto a C2 system and they'd be done. Users were supposed to get motivated by the fact that there was a range of products that they could buy, and because those were retrofit levels, they'd start to get into secure and evaluated systems with products that were compatible with the things they were now doing. Indeed, we believe that many users were already running ACF2 and RACF, and so the C2 evaluation would sort of endorse some things they were already doing. And the transition, B1 was mandatory security training wheels. That's due to Ted Lee, who used to work at UNIVAC or Unisys, as I guess it's now called. The notion that we'd take a not very assured system, bug-prone monolith, we'd add mandatory security, and then users would get used to managing and using those controls. Application vendors would get used to building applications that ran under those controls. The rating would be easy and immediate, and the model would extend. The application would extend when you started to build B2 and B3 systems with real security, and users would be able to gracefully make the transition to multi-level. So in 84 and 85, there were a batch of initial evaluations granted based on the existing systems that were actually the models for developing the Orange Book. ACF2 and Top Secret got their C2s. The SCOMP, which is still around as the Wang XTS, got its A1 in 85, I think. I may be off by a year, 84, 86. Multics got its B2 maybe a year later, 87. And the other vendors were acutely concerned. I mean, I was at DEC and we didn't have anything rated in that first round, and that was a source of great concern to us. So we were putting a lot of energy into getting the C2 for our mainstream product, thinking about how to get to B1 with that mainstream product, and building an A1 system. And most vendors were trying to develop most at B2 and above, and everybody was doing C2s. So that was the picture in 1985, 86, 87. Of course, when I say most vendors, I'm talking about a batch of companies that aren't in business anymore. Talking about Burroughs, I'm talking about Digital Equipment, I'm talking about Control Data, I'm talking about UNIVAC, not Unisys, IBM certainly, but you know, I mean, I suspect I just named some vendors that some of you have never heard of, or certainly don't associate with building computers in their own operating systems. It was a very, very different world. And what happened, one of the things that happened was that the process got more rich or formal or structured with the need for consistency as all these products came into evaluation. And because of that, we had what were called interpretations of the Orange Book that had the effect of adding more rigor and structure in the areas of documentation, features, and testing for the C2 systems. And in part because of that, and in part because maybe people underestimated the challenge, the duration and cost of the C2 and B1 process grew compared to what those of us who were involved in the initial development of the Orange Book had expected it to be. So VMS got its C2 initially in 1985, I think, but then the next version, which we thought was just an upgrade and adding mandatory security, took 7 years. Actually, that was from VMS 4.3 to VMS version 6, with a lot of intermediate releases along the way, and 7 years. Sun asserts that their B1 compartmented mode workstation, which has not yet been evaluated, I mean, it's still a candidate for B1, has cost them $50 billion of development cost over, I don't know, 1998, maybe 10 or 12 years. You're talking real money, okay, for C2 B1. And what did I say about C2 and B1? Yeah, it's junk. I probably would rather this lecture be more or less on a non-attribution basis if I'm going to use words like junk, and I'd rather use I'd rather use words like junk and at least keep myself honest. So, you know, you've got these kind of costs, and in part because of that, the B2s dropped. Okay, we went from everybody doing B2 and above to basically nobody except Wang sticking with it. Wang and Data General, I guess, are the folks at this point who are doing real operating system B2s. And the reasons were cost, market. I remember during the days of my A1 system having a visit from an Air Force officer who was a good security guy, good friend, longtime acquaintance, who came and listened to our briefing and said, "Steve, nobody wants an A1 time-sharing system anymore." The market moved on to PCs and workstations, client-server networking, and we were stuck building A1 systems, B3 systems, back in the time-sharing era. You could take another round, but the development cycles for that level of assurance were so outside the mainstream and so long that, you know, by the time we had done an A1 for the PCs and workstations as they existed in 90 or 92, you know, there'd have been another revolution, another cycle, and we'd be behind again. And that was the reason for those cancellations, in my view. I mean, we used to talk at the time, it was good market politics to blame the export restrictions on highly trusted systems, and certainly I'm as guilty of having done that as the next guy. But the fact of the matter is that we and others canceled our A1 systems and our B3 systems because we didn't think enough people would buy them. And if we shipped them, we'd sell some, but it was cheaper to write off the development costs and cancel them than it was to ship a few and then be stuck supporting those customers for another 10 years. So that's the dynamics of the market. So what happened, you know, I mean, with 7 years to C2 and no systems evaluated higher, what really happened in the market? Well, you know, you still have procurements, and the procurements still mandate evaluated systems, and so users make their own rules, their own interpretations, if you will. The MS 4.3 was in fact evaluated as a C2 system, so the users said, well, that's good enough, we'll use 4.6, 4.7, 5.0, 5.1, based on that evaluation that was 5, 6, 7 years ago. It was evaluated on some specific piece of hardware, VAX 8600. That's probably also something that's before most of you were born. But we'll use other processors, and it's all about the same. It was evaluated without a network, but nobody in his right mind can operate with a network. So, you know, it's a C2 system, and we'll operate it networked, and that will be okay. The users do what the users do. Back to the email that Cynthia was talking about, and back to the Ware report. Remember, we said that, you know, to do real multi-level, unclassified up through secret, you know, you want B3, you want some assurance in there. When I was with Trusted Information Systems, we had a government consulting, you know, contract operation, and somebody came to us with a network, a computer network, and they wanted us to do a penetration test as part of an evaluation for operation. And this system This network had the SIPRNet, secret, up here at the top of the diagram. And it had the internet down here at the bottom of the diagram. And in between, you had this mess of stuff, is the best way I can describe it. You know, there was a network, and there was a CMW, and there were some Unix systems, and there were some PCs. I don't think there were any NT systems at that time. It was a little too early for that. But there was Novell, and there was Sun, and there were other, maybe digital and other things. But the highest assurance component in that was probably the CMW, which was probably an unevaluated, like to be B1. And so, you know, you have secret here, you have unclassified here, you've got a lot of stuff in between, and that's protecting the secret data. And that's the way people are operating today to get their jobs done. Maybe a little scary. Meanwhile, what happened, you know, out in the rest of the marketplace is that you can buy much more security stuff than you could 10 or 15 years ago. Firewalls, people making fortunes on firewalls, security configuration managers and intrusion detection systems, encryption and tunneling products. I'll tell you some funny stories about tunneling products if you get me started, although I don't have slides about them. The authentication token gadgets, virus scanning, and that's all because of the internet. I mean, 6 or 8 years ago was sort of the low point for security products and security people, and then the internet got people connecting their internal networks and systems to that great world out there. And I guess a few things happened, and you know, certainly, I mean, you know, there were Mitnick, there was Morris, there were other things that got publicity, and certainly people became aware of that, and as a result, they wanted security, and vendors were there to provide it to them with all this stuff, firewalls and virus scanners and what have you, and so they bought. C2-like security is in fact in most of the operating systems, server operating systems, multi-user operating systems that people buy. You know, they have authentication, they have access control, they have auditing. They may or may not have the evaluation. They probably don't in most cases, but they meet the intent, and users, some of them look for some C2 rating somewhere. And they sort of more or less understand the threats to their systems from the internet and from authorized users, and they do the best they can. They actually seek third-party evaluation, but because, you know, at this point, the government, the Orange Book style evaluations don't apply to a lot of the things they buy. They look at things like NCSA, the National Computer Security Association, and the trade press and that passes for an evaluation. And users sort of build what they can. You know, they cobble together firewalls and tokens and virus scanning and Java blocking for usual network configurations, and then they secure themselves and they more or less operate. And they build more interesting configurations, sharing information outside the confines of their enterprises, and they do the best they can. I don't think any of this is particularly, it's not unuseful, it's not adequate for classified information. So high assurance systems today are B1. I told you the story about this network that we were asked to evaluate for a government customer. They never let the contract with us. I think we licked our chops too much at the prospect of doing a penetration test on that network, and they withdrew the request that we look at it. But they do the best they can, and high assurance is B1, so that's what they use. Now, the common criteria and the evaluation process that are evolving, yeah,
Can you go back to the previous slide?
sure.
I'm not going backwards. So you're saying, in your view, that's what you see being deployed?
What I see is people using B1 systems and CMWs in configurations where 15 years ago we would have told them to use a B3 or an air gap. Okay, but an air gap is not operationally acceptable, and a B3 system for the most part is unavailable. So, you know, they plug things together and away they go.
So you're talking about military and government
Yep,
systems?
military and government systems. Yeah.
Have you been approached by any of the electronic commerce people like, you know, eBay or Amazon.com or the banking brokers or any of those guys that now are touting secured socket layer encryption, the 128-bit, like that's the answer, and once you have that, no problem about your credit card, no problem about your stock account. Is that a facade or is that really useful and that's not
I mean, those are...
those guys come to you? I'm sure they're...
Well, I mean, okay, MITRE Tech works mostly for government, so they don't. I mean, they did come to us, you know, when I was in the commercial world at TIS, and they used our products. Secure socket layer. I mean, you know, I'm not a cryptographer, although I mean, you know, but I believe it's probably fine cryptography. The question is exactly what are they doing with, you know, exactly what are they doing with the web servers behind, you know, that are terminating that secure sockets layer, okay? And in some cases, I suspect that, you know, between restricting access through firewalls and restricting the application set of software that runs on those systems and configuration management and so on, they're probably in pretty good shape. But you know, I mean, I think you can make the case that you know, the credit card numbers on those systems are not necessarily as sensitive as some of the information that the government needs to protect. That's one comment I would make. And the other is that the applications, you know, while they're very high transaction rates, they're not as rich as some of the things. I mean, you know, the government, you can argue that that surfing the web from behind from a classified environment, or even SMTP email is more exposed or more exposing in some ways than just doing SSL to a web server. I told you I'd talk about encryption. I want to let me finish, but I have a VPN story that I'll tell you if I get finished before 1 o'clock. So what we do today, you know, the common criteria is really derived from the European ITsec evaluation criteria, and that basically says the user or the vendor specifies what he wants built, and then specifies one of a predefined set of assurance classes to which the system will be built, and the system will be built that way. Now, this has some downsides that we considered during the Orange Book debates, because, for example, you know, if I've got a firewall with feature set ABC, and you've got a firewall with feature set ADF, and we each get them evaluated, how does the user decide which one is right? That's probably less important for some of these specialized products, probably more important for operating systems. You know, and we also worried during the evolution of the Orange Book that procurement specs would be loaded for some vendor, you know, in this kind of a model, that procurement specs would be loaded for some vendor who wasn't us. the variety of products in the Orange Book days was less. There were operating systems or operating systems. And so today, I think probably the common criteria is a reasonable and practical approach. Certainly increases the evaluation bandwidth. You have commercial labs doing the evaluations and the government monitors, and that's a quicker process than having everything thin-threaded through a set of government hired contractors who are doing all the evaluations. If there are more products to evaluate, the labs will hire more people and more evaluations will get done. And that's important because in the internet world, you know, the criteria are fast, fast, and fast. You've got to do things timely or it just doesn't matter. Building systems with 7-year evaluation cycles won't cut it. The U.S. NIAP, the National Information Assurance Partnership, which is the U.S. implementation, and the common criteria do let you evaluate new kinds of products, do let you evaluate current versions, let you evaluate at a reasonable cost. We took the Gauntlet Firewall 3.2 version through a European ITsec evaluation, and in fact it got evaluated E3 to our protection profile before the next version had shipped. Not something that happens normally with the old C2 way. The other comment about rapid evaluation is, you know, don't get carried away, okay? These systems are junk anyway if there are 15 million lines of code down there. So, you know, don't kid yourself that you're getting every bug out. You want a reasonable level of consistency, reasonable level of documentation, but, you know, I mean, you're not going to get every flaw out of 15 million lines.
So you mean the operating systems, right?
Well, I mean, there's a lot of code. The operating systems, you know, are sort of the foundation, and they're big. I mean, I'll talk about big in a minute. And as I said, the other indications are positive. You know, the European firewall evaluations, actually U.S. commercial labs are doing evaluations under the NSA program called TTAP, and those are going out pretty quick. So I think this is probably good stuff. Comparability and competition still needs to be resolved. You know, loading of procurement specs and the like. And the question that nobody's really answered, and that, you know, sort of the mainstream marketplace really doesn't seem to care about, is whither high assurance. And the answer is that commercial users really don't need multi-level security, okay? There's sometimes a notion of data classification, you know, TIS sensitive, digital confidential. There's almost never a notion of clearance. Those classification labels are just used to advise need to know. Government multi-level security demand is not as big a deal to the vendors as it was 20 years ago. A, because defense is a less important fraction of the marketplace that vendors see than was the case 20 years ago. And B, because the defense users are giving up and say, the heck with it, just give me what I can buy and I'll make do. Meanwhile, downloadable code, Java, ActiveX, et cetera, manifest the threat that Bell and LaPadula were worried about in 1973. Okay? I mean, it's real. And there's still no mandatory security. I don't know whether there will be. It's not necessarily an encouraging picture. Here's my perspective on assurance. Okay, I talked about Lee Schiller's kernel for the PDP-11, and that was about 2,000 lines of a hideous programming language. The VAX A1 kernel was about 60,000. The TMOC kernel that was built at TIS and the Guardian kernel that was hypothesized for Multics but never built were about 250,000. And then a couple of data points, VAX VMS version 5 was about 8 million lines. and in the operating system, and Windows NT, you know, you hear various numbers, but all of them have lots of zeros. So assurance is tough if you want a full function operating system. I mean, this isn't because these are bad people. I know some of the folks in the NT group. They're smart guys. They're motivated. They're trying to build the systems that the customers want. And if you don't believe they're building the systems that the customers want, look at the path of Microsoft stock. It's hard to say they're doing the wrong thing. Just that high assurance isn't high on their list, and you need Windows, and you need interprocess communication mechanisms, and you need networking, you need all these other things, and those add code, and partitioning the system up so that there's a small TCB in the middle that you can assure costs time and money and performance that their users haven't told them they're willing to pay. Somebody had a question up here. You,
I did.
yeah.
I noticed you went from 60,000 to 8 million lines of code for, you got the VAX VMS version 5. Is that because you introduced symmetric multiprocessing?
No, the SVS was an A1 system. VMS version 5 was a C2, okay? So this was our approach, and their papers. I don't know, have people read the papers? Have you assigned them, Cynthia?
Maybe not this class.
Okay, I mean, there are papers, I can give you the reference, or Cynthia can, about how we designed SVS to run. Basically, it was a virtual machine monitor. It mimicked the interface to the operating system, mimicked the interface to the hardware. And what that let us do was to run any Unix or VMS system designed for a VAX on the security kernel, okay? And when you got a new release, we did that when we went from 5 to 5.1 of VMS, you just take the upgrade tape, blast it onto the virtual machine, and now you had a VMS 5.1 system running on the A1 environment. It had some limitations, performance, hardware hacks that we had to do, and just the usual feature stuff. I mean, you couldn't get to workstations, you couldn't get to networking without going into the kernel. So development got expensive as you wanted to add features, even though most of the features were outside of the trusted code. And the limitations in performance and functionality just killed that system. But it was an interesting approach. That's sort of a side note, but it's a paper. I mean, the papers on that system are worth looking at. Covert channels are still a hard problem. As we tried to build the A1 SVS, the same system I was just talking about, we discovered that modulating things like disk use and processor use and stuff allowed you to send messages, okay, covert channels in violation of the policy. And we cleverly built a fairly brilliant set of mechanisms that went by the name of fuzzy time to defeat those covert channels. And those were published in the IEEE Oakland Conference Proceedings 1991. And then a guy at NRL developed a model that defeated the fuzzy time mechanism and allowed a covert channel to signal anyway, and published that in the Oakland Conference 1992. I'm not sure how much you can do about covert channels. The other thing is that users and applications still need to send information, across the classification boundary. Email, ops, intel interfaces, and so then you have the steganography problem of hiding information in the flow back from high to low. And I think that's an area where we really could use a theoretical breakthrough if anyone has one lying around. Okay. So there are lots of research topics left. Covert channels and confinement I just talked about. One of the questions that I pose is that the Gauntlet firewall application itself, for example, other applications, SSL, what have you, are probably relatively small, and they're designed for security, even though they're running on one of these bug-prone monoliths. So the question is, is there anything that you can say in the presence of this miserable, untrusted operating system? If it's not hostile, is there anything meaningful you can say? And we've been waving our hands at that for 25 or 30 years. And I don't know that there's a conclusive answer, but as difficult as it is to get A1-like operating systems, maybe that's something people had better look at and make some strong statements about. There are high assurance components. Wang is still selling the XTS 300. I guess that's the remaining A1 system. What's the most powerful way to use those? Cryptography gives you a lot of leverage in terms of being assured that information won't be disclosed or modified. What are the best things you can do to integrate cryptography into highly assured systems and take maximum advantage of this? I mean, I can pass encrypted data to my 6 million lines of untrusted code, and I can still be sure it won't disclose the data by breaking the cryptography. It won't modify the data without being detected by breaking the cryptography. It may do other bad things to me, but that's a strong mechanism to build on, and maybe those are research directions that I think ought to be explored. So what now? I'm out of time. Fortunately, I'm out of slides. No silver bullets. I owe that to Fred Brooks, of course. Lots of opportunities for research. Meanwhile, defense systems are going to continue to use COTS components, and users ought to understand what it means when they've got the SIPRNet here, the internet here, and a CMW as the strong point in the middle. Sometimes the answer, and I have a consulting role for some government customers, sometimes the answer is just say no. I mean, you can't do that. And sometimes they don't want to hear that, and sometimes they listen. I mean, I think the smart ones listen, because in today's world, there's some things that you can do that you just shouldn't. So I don't know that that's an especially optimistic perspective on where we've gotten to in the last 30 years. I think it's a realistic one. Certainly, if you're interested in doing research or advancing the technology in security, the need for people to do that isn't going to go away anytime soon. I'll take questions until you get fed up and leave.
Tell us about the VPN.
Tell us about the VPN. Yeah, well, you can buy, there's a straight man in every crowd. You can buy these products called encrypting tunneling clients, okay? There are a variety of them. The Checkpoint Firewall one, Secure Remote is one, Alta Vista Tunnel is another. There are others. And what they do is to sit on your PC, and then you communicate over the internet from your PC to your home system, and they provide encryption of the traffic between the PC and your home. So people use that, and they configure it to give you access to your inside protected network with your corporate sensitive data on it, okay? But your PC is still on the internet, okay? So if I can get a Trojan horse onto your PC, then I can go back through the encrypted tunnel into your inside network, and I can suck down anything you have access to off your inside network. Now I mean this is a wonderful example of synergy. We hypothesized this attack, and we further hypothesized that the best mechanism to exploit that vulnerability would be basically an interpreter that would sit on your PC, and I'd shoot it commands, and then it would probe your inside network from your PC at my command. And so rather than have to do a tailored attack, I just do this general purpose thing, and it would do anything I wanted it to on sort of an interactive basis. Well, there's something called back orifice, if you've heard of it on the Hacker Bulletin Board, and it's just tailor-made for installing on the PC of somebody who's using one of these client tunneling VPNs to access an inside network. And I don't know whether that was the motivation or it was just general nastiness. But the thing's out there, and I mean, you see that on the internet bulletin boards, and you say, gee, I love it when a plan comes together. But the important thing is that there are users, commercial users who should know better, who are deploying these client VPN tunnels to access their inside networks, and thinking they're operating securely over the internet. More questions? Okay. People have to go to class. Thank you very much for coming.